Good evening. In this video session, I would like to discuss about the Hermitage uh, polynomial or Hermitage-cubic spline. This Hermitage-cubic spline is a third degree equation. So normally you have 3 points x, y, z. This can be represented with a parameter p. So this is equal to C0 constant plus C1 into U plus C2 into U square plus C3 into U cube. So this is a cubic equation and U is varying from 0 to 1. So depending upon the values of coordinates x, y, z point, to determine the value of the corresponding point. So here, to determine the unknowns C0, C1, C2 and C3, what is that you have to perform is the boundary conditions. So given 2 points, u is equal to 0, x is equal to x1, y is equal to y1, z is equal to z1. U is equal to 1, x is equal to x2, y is equal to y2, z is equal to z2. So depending upon these two boundary conditions, to determine the values of C0, C1, C2, C3. Basically, in the problem, you will be given 2 points, and these 2 points are the 2 coordinates, x, y, z coordinates, x1, y1, z1, and another point is x2, y2, z2. At u is equal to 0, the point is x1, y1, z1. At u is equal to 1, the point is x2, y2, z2. In between, we have to say 100 points. That means 1 divided by 100. So every time you are implementing that value, and you're trying to find out the corresponding point coordinate of the curve. So to do that, basically what is that you have to do is to find out the constants C0, C1, C2 and C3. See here, P0 is equal to, so u is equal to 0. If you put u is equal to 0, you get the point at the first point, that is C1 is equal, this is 0, these 3 constants are C1, this is equal to C0. And P, see here I am writing P dash U is equal to C1 plus 2C2 U square plus 3C3 2C2 U plus 3C3 U square. So here if you put U is equal to 0, the tangent at that is P1 is a tangent. So here already P1 is a tangent at U is equal to 0 and it is equal to C1. So x0 C0, y0 C0, z0 C0, x1 C1, x2 C1, x3 C3. So 2 points over 2 constants. Now we have to find out C2 and C3. So if you put u is equal to 1, what will happen? 1, 1, 1. So P1 is equal to C0 plus C1 plus C2 plus C3. Okay, and so this is P1 dash. Sorry, P0 dash. And that 0 is equal to u is equal to 0, P is 0. Similarly, P1 dash is equal to how much? C1 plus 2C2 plus 3C. So here you have 4 unknowns and 4 knowns. P0 is known, P0 dash is known, P1 is known, and P1 dash is known. So 4 equations are there and 4 unknowns are there. What are the 4 unknowns? C0, C1, C2, C3 are unknowns. So C2 plus C3 is equal to P1 minus C0 is P0, C1 is P0 dash. Here 2C2 plus 2C3 is equal to 2P1 minus 2P0 minus 2P0 dash. Now 2C2 from this equation plus 3C3 is equal to P1 dash. C1 is what? P0 dash minus P0 dash. So if you solve this equation, subtract and subtract, minus plus, this will cancel. So minus C3, 2P1 is there. 2P1 means first you will go for P0. This is minus 2P0. So minus 2P0 will be having. Okay. Plus 2P1 we are having, plus P0 minus 2P0, that means minus P0 dash and minus P1 dash. So C3 is equal to 2P0 plus 2P1 minus 2P1 plus P0 dash plus P1 dash. So you got the value for C0 is x0, y0, z0. Value for C1 is the tangent at x0 at the 0 point that you got. C3 is, this is the C3 equation. So here from this I have to calculate C2. Now what is C2? C2 is equal to P1 minus P0 minus P0 dash minus C3. Minus C3 is how much? This is I think. The base product is minus 2P0 plus 2P1 minus P0 dash minus P1 dash. So here C2 is equal to first P0 terms. How many P0 terms are there? Yes, 0. That means minus 3P0. Next P1. One P1 is here, another P1 is here. P1 plus 2P1 plus 3P1. P0 dash. Here one P0 dash is a P0 dash minus 2P0 dash. And P1 dash, how many P1 dash are there? There is only one P1 dash. It is minus P1 dash. Minus P1 dash. Now, you can write down this equation. Pu. Now, U can be anywhere between 0 to 1. And C1, C2, C3 are the constants value set 0, U is equal to 0 and U is equal to 1. So, this is equal to C0 is how much? What is the value of C0? P0. P0 plus C1 into U. P0 dash into U plus C2 is how much? This is C2. Okay. Plus minus 3P0 plus 3P1 minus 2P0 dash minus P1 dash U square plus C3 is how much? This is C3. 2P0 minus 2P1 plus P0 dash plus P1 into U. Now, from this equation, you have to separate the classify P0, P1, P3 separately. So if I take P0, what are the values? P0 is here, minus 3P0 is here, is 1, minus 3U square. This is U square. And here P0 is there, plus 2U cube. P0 into 1 minus 3U square plus 2U cube. Next, plus P1. What is the P1? Then 3P1 is there. 3U square. And here 2P1 is there. That's minus 2U cube. Plus P1 dash. P1 dash is here we are having P1 dash. In this P1 dash, we have to have minus U square, and P1 dash is this P1 dash. P1 dash is plus U cube into P0, P1, P0 dash. So this is P1, this is P1 dash. Now we will go for P0 dash plus P0 dash into U is there, you can write U, and P0 dash is there, it is P0 dash, minus 2P0, that is minus 2U square, that's 2 square, is it? And here P0 dash is plus U cube, plus U cube. And this is the equation, this is PU. So this is the equation what you have to use in our algorithm. And U is varying from 0 less than or equal to U less than or equal to 1. So between this 0 and 1, you know, that is you have to give x1, y1, z1, x2, y2, z2, and the tangent values, that is there are two tangents. So tangent at the beginning is 45 degrees or 35 degrees. So that you have to x component of the tangent, y component of the tangent. That it is. So it vary the value and use this parametric equation to draw a beautiful Hermitage cubic spline. So this is what I would like to discuss. Thank you for watching the video.